Hello everyone, good morning, and I hope you guys enjoy today's event at the PyCon Hong Kong. Just a bit background about myself. My name is Peter Ho, and just like the MC just mentioned, I'm one of the solutions architects at Red Hat Hong Kong, mainly helping customers to really build or architect system designs, especially for enterprises and for Hong Kong governments. And today I'm very happy to have this opportunity to go on stage and to talk a bit about the latest development of LLM inference. Right? LLM inference is a term for running the AI model. In case you don't know what it is, and I'm going to introduce a bit about vLLM and compare it with another popular option, Ollama, and let you know why vLLM could be a better choice for you and or for your company or for your startup or whatever, right? First off, I would like to start off with a recent news, in case you guys are not familiar or haven't heard about it. And also this news kind of reflects why enterprise I'm seeing kind of really need or demanding the need for private AI solutions to run their own AI on premises, on the laptop, on the servers, etc., rather than on public cloud or any SaaS services. Back in August this year, there were 2 security incidents happened. You can just Google, and one of the incidents was about there are like 100K ChatGPT chats being leaked out on Google search. That means whatever you type in or you chat with ChatGPT, some personal stuff or some very confidential stuff, well, there may be an opportunity that is already being leaked out by Google or by whatever, right? You can just Google. I don't know why, right? But that happened. Another incident, same month, just within August, but this time for Grok, the Elon Musk model. Again, hundreds of thousands of Grok chats being leaked out. No one knows why, right? So that kind of creates an alarm for enterprise by looking at this, because enterprise, they have a lot of confidential data, or even for personal people like you may have your own medical healthcare being uploaded to ChatGPT, and you don't want it to be exposed to other parties. So that's why a lot of people would like to host or would like to run their local LLM solutions, be it on their laptop, be it on a Linux server, etc., etc., so that they can maintain a full control and also full privacy instead of sending confidential data to internet, to any API endpoints. But the challenge here is that, well, I think this is also kind of specific to China, of course, including Hong Kong, is that we have very limited number of GPUs available because of the sanctions, right? Donald Trump, he just announced something, and then he just tried to stop NVIDIA's to sell in China, including Hong Kong. But on the other hand, when Donald Trump wants to sell again, I want to release it back to China, the Chinese government, turn it the other way around, don't want the companies to buy. So that is the kind of dilemma. But luckily, we still have quite a number of models that we can buy in Hong Kong. Particularly this one, the NVIDIA L20. Previously, we had the NVIDIA H20. I guess you all know on the news, right? H20, but no more. Right? H20 is being banned or not recommended by the Chinese government, except for a relevant reason, right? So a lot of companies will try to buy this L20 card, but the problem here is the number of RAMs. The VRAM here is very limited, just 48 gigabytes of RAM. Well, maybe I'm not sure how many of you are gamers here. So maybe you can say, 48 is very large already, right? But if you look at the model that you want to deploy, for example, right, talk about DeepSeek, the full version is 671 billions of parameters. I'm not talking about to deploy this kind of thing. Just imagine you want to deploy a very small scale, just like 70 billions of parameters, which is like 10 times smaller than the DeepSeek one. Just 70 billion. The memory required for a 4K context lens is talking about 165.5 gigabytes of VRAM. That means how much? You can just divide 165 divided by 48. This is like 4 GPUs at least, right? In order for you to run. And if you go to ShopShaper or if you go to online shops to buy these L20 cards, one card is talking about 40K Hong Kong dollar, right? 40K. That means if you want to just run a small model like 78B, right? You are talking about like thousands of, hundreds of thousands of dollars of investment just for one model. And well, of course, you need something else. You need something to improve. You need something to save the cost, to improve the throughput, rather than spending a lot of money to buy a lot of GPUs. Because money is not unlimited, right? That is the fact. Of course, all you need is, well, not definitely everyone needs love, right? But here I talk about not love. You need vLLM, right? You need an open source solutions that is first allow you to run privately, of course, to cater to both those privacy concerns. Another one is that this LLM engine or LLM inference server itself has already bundled with some optimization techniques within it, so that it can help you to first increase the LLM token generation throughput, second, reduce the latency, and of course, third one, reduce the number of VUMs needed, so that reduce the number of GPUs. So that is the value of vLLM. And well, a lot of people, I guess you guys, most of you are developers, and I'm sure you have already heard or even been using another open source project called Ollama. I'm not sure why it's flashing, by the way, but yeah, it's just like it is, right? And Ollama is very good. It's very good because it's very convenient. You can just run a single command and then start using a model or whatever. But the challenge of using Ollama is that if you look at the source code, on GitHub, it is not designed for multiple users. It's not designed for concurrent situations. But on the other hand, vLLM is designed for multiple users, talking about larger scale, enterprise scales. If you have like 10, 100,000 or even more users accessing, requesting, generating tokens, or requests at the same time, then you should consider vLLM instead of Ollama. Why? Just look at this diagram. This diagram shows a benchmark result compared against Ollama with vLLM. And this one is talking about the output token per second, which means the throughput. And of course, higher the better. The blue one is vLLM, and the orange one is Ollama. If you just have one, concurrent users, for example, this one, of course the performance is very similar, right? Not much different. Maybe vLLM perform a bit better. But once you start to increase the concurrency, 2 users, 4 users to 256 users, you can see the dramatical difference. It's exponential increase. And you can see Ollama will always keep constant in the number of token generation. Because again, it's designed for one users. It's not designed for multiple users. So that's why Ollama is not scalable. Another diagram. Another benchmark, latency. This time, the lower the better. Again, right? The orange line is Ollama, the blue line is vLLM. And once the users start to increase like 2, 4, to 128 to 256, you can see the latency, is increasing exponentially. That means it's not good for you to run so many users with Ollama. But on the other hand, VM is kind of constant. This is a steady growth, right? This is very important because if you have very large latencies, the users or you guys cannot accept because the token will just generate and your reading speed is longer than the latency, and you will get very frustrated. But why VM is so powerful? Because there are so many, so-called state-of-the-art technologies that the open source community bundle with the vLLM, including something called the, continuous batching, flash attention, speculative decoding, parallelism things, page attention, prefix caching, blah 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 blah. A lot of things. I know these terms may be, kind of, fuzzy and also kind of feels like a buzzword to you. Maybe if you're not in the in the LLM inference field, no worries. I'm going to explain some of them later on. But just remember, vLLM itself bundles a lot of optimization techniques that is designed for multiple users. The first one, talk about the parallelism. What parallelism means is that when you run a model, you can run a single model using multiple GPU cards. For example, you have like 4 or 8 or even more NVIDIA cards. You can just group them together and then run your model so that all the cards can run the model simultaneously and they boost the throughput. And there are multiple ways that you can implement parallelism. The first one is called the tensor parallelism. So tensor parallelism is just like having a model. For those of you who know how model works, is a model is basically consists of a bunch of model weights, right? Model weights or parameters. What tensor parallelism or TP does is they shard or split the model. For example, there are like 4 billions of parameters, for example, and I have 4 GPUs. And if I use TP, then each GPU will be responsible for the compute of 1 million of parameters, right? So this is how tensor parallelism works, and in parallel. Another one is pipeline parallelism. Pipeline parallelism is just like a sequential processing model. For example, again, talking about like neural network, architecture. Neural network architecture is consists of like multiple layers, right? Maybe 50 layers or hundreds of layers. And then you can shard or divide or split, not by the weights, but by the layer. For example, the first GPU responsible for taking care of the first 20 layers. Second one is 21 to 40, and then 41 to 60, etc., etc. And then you can do that using parallelism, the pipeline parallelism. And the third one is kind of like a new paradigm. It's called expert parallelism, especially after DeepSeek emerged. Remember what is the power of DeepSeek? DeepSeek successfully, use the mixture of expert model in a very large scale way. So that if your model support mixture of expert or MOE model, right, you can speak according to expert, the number of expert that it architects or it is designed. For example, in DeepSeek, I can't recall the number of experts. For example, 16. Then you can start based on the 16. You have 4 GPUs, and then you have the first GPU running 4 experts, another one running the 5 to 8 experts, etc., etc. So that can increase the throughput and also boost the power, not just use a single one. And by the way, Ollama only support pipeline parallelism, right? If you talk about tensor parallelism or expert parallelism, you have to go for vLLM. Another one is continuous batching. This is very important, and this is also the reason why Ollama is underperforming, because it doesn't have the continuous batching mechanism. The idea of continuous batching is just like you go to a restaurant or you go to Cha Chan Tang, right? If you go to Cha Chan Tang, they always ask you to sit with others, right? Even if there's just one seat, right? Just like that. Whenever there's space, the staff will just feed in new requests, feed in new guests into the restaurant, just like in continuous batching. Without continuous batching, what it means is you have to wait for all the requests within the batch to process to complete in order for you to start a new batch of requests. That means, for example, in a dynamic batching way, which is not ideal, is that if you have a very long request inside this batch of processing, that need to handle, for example, like rack generation, a long request. But we need to wait until that rack request being completed in a dynamic batching. That means others need to wait, right? But for continuous batching, it's just like just now, I mentioned about the Chan Tang, right? Is whenever there are new spaces, I fit in this gap with new requests so that I maximize the throughput, maximize the processing power. So this is continuous batching. Another thing that vLLM provides is prefix caching. Whenever you design a LLM chatbot or LLM system, there must be some kind of system prompts into it, especially if you're designing agentic AI. For example, in this case, there's a system prompt highlighted in orange here. So that means every request that user sends, even though they do not aware, there's some initial embedding into the prompt that it needs to be sent to the LLM. But think about this way: if you can look into it in a detailed way, you can see this kind of repetitive. every request you have 10 users, this kind of repetitive, repeat and repeat again. That means the computation is also repeated, right? So what it does is that the LLM in vLLM, it doesn't recompute this KV cache for this again and again. It will just somehow store the KV cache for the initial prompt or for system prompt. So that whenever a new user request comes in, for example, someone asks what is the capital of France or what is the future of AI, well, the first part of the prompt is never recomputed. It's being cached in the system. That means we can save space and also speed up the computation. Another thing is called speculative decoding. What is speculative decoding? And someone called multi-token prediction. So this is, again, only available in vLLM, not available in Ollama. Is that we kind of use a smaller model, we call it a speculator here, to predict some common words. Because I'm using a smaller model, that means the computation power or computation requirement is much smaller than using a larger model. For example, if you look at DeepSeek, right? DeepSeek, maybe the larger model is the 671 billions of parameters. Look at what the full version. But the small version, maybe I'm using a distilled model, maybe just 70 billions, or even smaller, maybe 32 billions of parameters. I use a smaller model to help to predict, the tokens. And once the smaller model predicts a token, and it fit into the large model, and then to do the validation in a parallel way, using one pass, forward pass in the neural network, right? Whenever there are new words, then fit in the large model and verify. And because it kind of makes an assumption that majority of the words are kind of repetitive or simple. For example, is MR words word or just numeric stuff or some grammatical stuff that can be predicted by a small model. And then later on using a larger model to evaluate and correct the incorrect responses. So that is the way how speculative decoding works. So as you can see, using a combination of larger model and a smaller model together, that kind of speed up the processing. Traditionally, if you use a larger model, maybe you need to predict 10 tokens, and of course you need to maybe 10 requests of time. But in a smaller model, because one token generation doesn't take a full one slot of time of a larger model, maybe just one tenth of it, then it means a much faster speed in terms of token generation. And the other thing is about KV cache quantization. For those who coming from computer science background, I guess you know what quantization means, meaning that you reduce the precision of the floating point of the model weights or the KV cache value. A lot of models on Hugging Face that you can find are floating point 16 or BF16. And right now, people are trying to moving out from 16 bits to 8 bits or even smaller to 4 bits, right? But the problem is if you have a model that is, for example, talk about like the OpenAI, latest open source model. It was trained using 4 bits. Okay, that is very good. But the problem here is that you need to have a runtime to support the 4-bit model. The analogy is like that. For example, just imagine back in the days when you had download an MP4 video file. And I'm not sure you guys whether you are old enough or not. Maybe not. Is that, but in my generation, is that whenever you download MP4 and you have to install a video decoder, right? And if your MP4 file doesn't encode it in that way and your decoder doesn't support, you cannot run, you cannot play the video. Just like here in the vLLM or the LLM engine. So you need to find a LLM engine that supports a lot of quantization models so that you can run whatever model you need. And that is the power of vLLM. So we support a lot. And of course, we can boost the performance, right? If you quantize the model or compress the model, the gray one here, right? Talk about like H100 cards, and talk about like 2.2 requests per second, using 16 bits of model. But if I compress it into like an FT8, 8 bits model, I can boost the throughput to 4 times more without adding a lot of GPUs. That means I don't need to add 4 more GPUs. I don't need to spend 4 times of money in order for me to boost the throughput. I can just use quantization with vLLM. Okay, and the result is all very obvious, right? Faster and much better user experience with the VLLM optimization. With all the optimizations I just mentioned, prefix caching, KV cache, quantization, static decoding. And today's topic, of course, if you look at the talk, right, we call it a de facto standard for private LLM. Why? Because one of the reasons is that if you go to GitHub and look at the contribution and also the number of stars, is keep rising. There are almost 60K of stars already in the VLLM project, and it keeps rising. Another thing is that you can run whatever model you want, especially those models available on Hugging Face. So Llama models, the QN from Alibaba, or DeepSeek, Google, Gamma, Mistral, OpenAI, Microsoft, or even other Hugging Face models are available and also runnable on vLLM. Another thing is that vLLM supports not just NVIDIA GPUs, it supports other, they call AI accelerators, they don't call it GPUs. For example, AMD Instinct, Google TPU, Amazon's, those inferential or Trainium, that kind of thing, called neuron architecture, right? Intel Gaudi, or even some Chinese-based, AI accelerators. So you can run across anywhere. On your laptop, physical servers, virtual environment, VMs, private cloud, public cloud, Kubernetes, or even edge servers. Okay, so going back to Python. So how we can use vLLM in Python? Very simple. You just go to pip install vLLM, and just import the vLLM package, and then just call the LLM method or the function, and specify the model that you want to run, and then you will immediately go to Hugging Face to download the model for you, and specify the sampling parameters, and then your prompt, and then do a generation with your prompt and sampling, and then output the token. Very simple one, right? Another one is talk about online inference. Online inference is talk about building a real-time chatbot or real-time RAG system or even agentic AI. And in that case, you usually will use a command line to run the VM model, VLLM server instead of using Python. So you will go to Linux and then run this Linux command, vLLM serve with a model. And right now here I'm specifying tensor parallel. That is I'm leveraging 4 GPUs at the same time. And once you run the model, and it will provide an OpenAI API compatible endpoint. It's a RESTful endpoint. Then you can replace in your traditional LLM application. For example, if you are using the OpenAI library or package, you can just keep using that. But now you are pointing the base URL to your local environment, local VLLM server instead of going to public cloud or even other SaaS services. So you can, it's kind of like a drop-in replacement for different kind of OpenAI compatible endpoints. And of course, it can integrate with others, right? It can integrate with LangChain, and you can just use the vLLM, object here, right? And Llama index, again, similar, very similar code. vLLM object here specify the model, and then you can just do LLM complete to do a code generation, token generation, right? Very simple one. And there are a lot of examples online. If you're interested to know more or want to have get a hands-on or get your hands dirty, please visit the vLLM official documentation. There are a bunch of Python code examples that you can download and you can feel free to change it. So the last part I would like to spend a bit of time to talk about what Red Hat is doing with vLLM. The reason why we are here is that of course we want to promote this great project to the community, especially to developers like you guys. Another one is that I would also really like to talk about is that we acquired a company back in January this year, right? We acquired a MIT-based company, right? In Boston called Neural Magic in January. So what Neural Magic does was it was a company who was built or established mainly to help customers to optimize AI deployments or AI models, right? So we acquired this company with all those like PhD, researchers and also those, people from Google, etc., and then to join our company. And right now, we are kind of, building our own solution using the open source way, right? We are packaging the vLLM and also other things. We have other sub-projects of vLLM called LLM compressors, who can help you to compress the model, by the way. And also another project called LLM. LLM is a command line tool to help you load test or benchmark your LLM engine performance. So can we kind of bundle all these open source projects together into a single, well-supported, hardened, tested solutions we call Red Hat AI Inference Servers. So in case you or your companies would like to have a supported version of vLLM, because vLLM itself, well, it started to get complicated. A lot of people are trying to contribute, and there are a lot of parameters that you can tune, and it keeps changing very fast. And you want someone to support you, then Red Hat is a very good target or very good company to help you to achieve that. Especially for enterprises, if you are concerned with privacy concerns or compliance concerns or security concerns, operation concerns, then you should go to find a Red Hat, right? And because of the acquisition, right now Red Hat is becoming the #1 commercial vLLM contributor on GitHub. If you just look at the GitHub contributions of vLLM, I'm not talking about those individuals. Those individuals may be like professors, researchers. I'm just talking about the commercial companies, right? Those companies who build solutions and then sell it to companies, right? Red Hat is #1 here. You can look at the diagram here. The blue line is Red Hat. So that what is the implication? What is the meaning of this? That means Red Hat is already shaping the community. That we are empowering the community to use vLLM, and we have the expertise, we have the skills, and we have the domain knowledge in the case of vLLM. That means if you need help, well, Red Hat is the way to go. And if you go to YouTube, you can just also search. There may be a bunch of vLLM office hours. So these people who host or coordinate these events are all from Neural Magic. That means are all from Red Hat. Most of them are from Red Hat people. So that means we are kind of the pioneer of vLLM. And back in China, a lot of people may be asking this, whether we have like influence in China. Yes, of course. And just like in August, like 2 months ago, we did a very large-scale community meetup with a hardware company called MetaX in Shanghai. So MetaX is very specialized in building AI chips, AI accelerators, and we collaborate with them to really shape the community in mainland China. So we are starting to get a lot of traction and also a lot of attention in mainland China as well. Okay, so the last thing that I would like to talk about is that besides vLLM, what Red Hat has been doing is that we also help a lot of customers to kind of pre-quantize or pre-compress the models for you. So just like I mentioned, a lot of companies are trying to use the full version of the model, 16 bits, but that is very costly, very hard to run if you do not have a lot of GPUs. So what Red Hat did was, or keep doing, right? Not Red Hat did, keep doing is that we go to Hugging Face and download all those open source models, including Llama, DeepSeek, OpenAI models, or QN, etc. Those popular models. We help you to compress it for you. And then after the compression, we open source those models again on Hugging Face. That means whenever you have a need to find any quantized or compressed models, if you don't know where to find, please go to Red Hat AI on Hugging Face, and you can find a lot. There are like 500 models available there already. So I would like to show a video here. Is that after the compression, what is the result? So here in this video, there are like a comparison between a non-compressed model with a compressed model. The left-hand side is the uncompressed model Llama 3.170B, not a full 16-bit. And on the right-hand side is a compressed one, a quantized one, also Llama 3.170B. But on the left-hand side, I use 2 GPUs. The right-hand side, the compressed one, I only use one GPU. And then you can see the token generation comparison. As you can see, the right-hand side is much faster than the left-hand side. Why? Because we are using quantized model, right? We are computing using 8-bit instead of 16 bits, so that's why computation is much faster, right? The latency is also smaller. But again, I'm only using one GPU. I'm just only using one, but on the other side is using 2. That means you need to double your cost. So that is the power, that is the value that Red Hat adds to customers or add to people like you. So if you're interested, just go to Hugging Face and download a model and then try it yourself. Okay, the last slide is talk about the future, right? This is a very, I don't know how far it will be, very soon, I don't know. Is that we have been launching a new open source project called LLM. I always want to tell a joke in Hong Kong is that don't mix up the LLMD, don't put the D in front of the LLM. Okay? Otherwise, we can't sell this product in Hong Kong, right? Or in any Cantonese market. Anyway, D stands for distributed LLM. Okay? So the idea here is to leverage Kubernetes to really, kind of optimize the way how the model works. There are a lot of technical details. I'm not going to spend a lot of time here. For example, they're like a optimized inference scheduler and also this aggregated serving and previous caching, if you know what I'm talking about. And also there's a hardware autoscale traffic and also autoscaler that you can install on Kubernetes. But the idea here is very simple. We want to design a system on Kubernetes that can scale to a very large scale and optimize the resources. And this project we have been partnered with a lot of vendors, talking about NVIDIA, Google, AMD, Intel, etc. So in case if you're interested, please feel free and check it out. Okay. I think I have one more slide. I'm not sure why. Anyway, let me just flip it. So last part, I know I'll overrun a bit. Sorry about that. Last part, I would just like to wrap up my presentation. Is that first, well, you have to consider about privacy, especially you guys have heard that there are multiple incidents happened, right? And I actually have one more. I just read a news on Reddit like 2 days ago. You just go to Reddit. I don't know why someone found that OpenAI accidentally reviewed who are the top 30 customers who are using OpenAI. And what are the names, what are the job titles, etc. Those customers' information are being reviewed on Reddit. You just Google. So that is the idea why people concern about AI privacy. That is not good, right? And vLLM is proven to be much faster than Ollama, just like what I mentioned. And if you have OpenAI API compatible endpoints, you can just drop in and then just replace it with vLLM. And of course, it supports Python, integrate with a lot of LLM frameworks like LangChain or Llama Index. And talk about Red Hat contributions, we are number 1. And the last one is that if you want to have Red Hat to help you optimize the model, please feel free to talk with us. Okay, thank you very much, and I hope you guys enjoy my talk. And please scan this QR code in case you want to connect with us or want to have more information, and we can have someone to reach out to you and to let you know more. Thank you very much.